We've been studying the properties of the graphs of rational functions, and in particular, we've been focusing on identifying four special features of those graphs: horizontal asymptotes, vertical asymptotes, holes, and zeros. And we had this worksheet B where we are analyzing each of the functions over here and filling in the horizontal asymptote, the vertical asymptote, the holes, and the zeros into this chart. So I'm going to just run through a few examples so you can see how this thing is supposed to go, and hopefully this will help you as you progress through the worksheet. Problem 1 is the rational function x squared minus x minus 12 over x. And before we do any real fancy math here, I want you to pay attention to the degrees of the polynomial. The numerator, the top function, is quadratic, meaning that the degree is 2. The denominator is a linear function, and its degree is 1. Since the degree on top in the numerator is larger than the degree on bottom in the denominator, we will not have a horizontal asymptote. So in terms of horizontal asymptotes, I'm immediately just going to label that as a none, and we'll fill that into the box on the sheet. After you've determined your horizontal asymptote, our next step is to go ahead and factor this thing and see if anything cancels out. The numerator, if I'm doing this correctly, which we know I'm prone to mistakes, the numerator factors as, let's see, I think it's going to be x minus 4 and x plus 3. And the denominator is already factored, it's just an x. Now, had I had matching factors that I could cancel, I would have holes in the graph. Since none of these factors canceled, I know there will be no holes. So for my holes, I'm going to say none as well. Okay. The remaining features are the vertical asymptotes and the zeros. When we're looking for vertical asymptotes, we focus on the denominator, and we say, when will that denominator equal 0? Well, that happens when x actually equals 0. So the equation of the vertical asymptote, which we always write as x equals and then some x value, for us is going to be x equals 0. That's the vertical line that acts as an asymptote for this function. To locate these zeros of this function, we look to see where the numerator will equal 0. And you can see that that's going to happen when x minus 4 equals 0. In other words, that x equals 4. And when x plus 3 equals 0. In other words, when x equals negative 3. And so when I'm listing my zeros, which is my fourth feature that we're looking at, I have 2 of them. And we'll simply list those as x-coordinates. So I'll say my zeros are negative 3 and 4. It's not an ordered pair, it's just 2 numbers, negative 3 and 4. Those are the places where this function happens to cross the x-axis if we were to graph this thing. And that's it. We got our 4 features filled in. You fill them in on the chart, and then you move on. This happens to be number 2 on that sheet. And again, you'll notice we're going to look at the degrees first of these leading polynomials. I have a degree 2 on top and a degree 1 on bottom. And when that happens, there are no horizontal asymptotes. So as I'm making a note of my horizontal asymptotes, I'm just going to say none. As we move forward factoring this rational function, in the numerator, I just have a GCF of x. And when I'll write it in blue, I guess. When I pull that out, it ends up being x times x minus 5. In the denominator, it's already factored. It's a linear term, x minus 2. And again, you'll notice that none of these factors cancel each other out. So for my horizontal asymptote, for my holes, I will also write none. There are no holes in this particular graph. There are, however, zeros and vertical asymptotes. So for the vertical asymptote, x minus 2 is set equal to 0, and that means x equals 2. So I have a vertical asymptote at x equals 2. And in the numerator here, there's two ways the numerator will equal 0. You set this factor equal to 0, which is just x equals 0. And you set this factor equal to 0. Oh man, that's messy writing. And you'll see that you get x equals 5. So for my wholes, there are two of them. And again, not wholes. Why do I keep saying the wrong things? I guess I could edit the video, but that wouldn't be any fun. My zeros are at 0 and 5. We're just going to list them like that. Okay, we cranked that one out. Let's look at a couple more. We move down the list. This is number 5 on our chart. This time you'll notice that the degree on the bottom is larger than the degree on top, right? It's degree 1 on top in the numerator and degree 2 on bottom in the denominator. And so when we have this situation, you remember from our notes that we do have a horizontal asymptote, and it's on the x-axis, and the equation for the x-axis is y equals 0. Anytime the degree on the denominator is bigger than the degree in the numerator, we write y equals 0 for the horizontal asymptote. Okay, now we can factor this thing. And this looks like a plus 6. And a minus 2, x minus 2. This time, you'll notice that we have matching factors in the numerator and denominator, so I can cross out the x plus 6. When that happens, that makes a hole in the graph. And that hole is whenever x plus 6 equals 0. So that happens at x equals negative 6. Now, that's the x-coordinate. We probably should indicate the y-coordinate of that function, and that happens when you plug negative 6 into the reduced function. When we cancel this out, remember there's a 1 there. So that hole is going to be located at negative 6, and the y-coordinate happens to be 1 over negative 6 minus 2, which is negative 8. So this is negative 1/8 for the y-coordinate. I'm throwing that extra little piece of information in. This is the y value that should be, that should have a point there, but in this case there's a hole there. And just remember that you can't figure out the y value until after you cancel stuff out. So I use this function to calculate that 1/8. All right, now let's talk about vertical asymptotes. We still have a factor left on the bottom, which is x minus 2, and when we set that equal to 0, we get x equals 2. That means we have a vertical asymptote at x equals 2. And finally, for zeros, we want to check the numerator, which is only 1 now, and 1 will not equal 0. So that's never going to happen, and so there are no zeros for this function. And so in this case, for zeros, we're going to say none, because there's no way to make a 1 equal to 0. So this function had some interesting features. We finally had a horizontal asymptote at y equals 0 because the numerator's degree is smaller than the denominator. We had some factors cancel, which means it created a hole. And the hole is at negative 6. And the y value where the hole would be placed or located is actually what you get when you plug in negative 6 to the blue circle there. So that was 1 over negative 8. And then we did a vertical asymptote at 2, and there were no zeros because there were no variables on top of the fraction after you canceled out the x plus 6. So that one had some interesting features. Let's just do one more, and then I'll be done with the video. This last rational function has some interesting features. First of all, you'll notice that the degree on top and bottom is both 2. When that happens, we do have a horizontal asymptote. And the way you figure out the equation for the asymptote is you write y equals, and then the value is the ratio of the leading coefficient on top divided by the leading coefficient on bottom. And when the term is just x squared, the leading coefficients are 1. So this is just y equals 1. 1 divided by 1 is 1. Once we have that taken care of, we will factor this thing. The numerator is a quadratic trinomial. Let's see, I think that's an x minus 2 and an x plus 1. That looks good. The denominator is a difference of perfect squares, and that just factors as x plus 1 and x minus 1. And you'll notice that we do have a factor that cancels. So there's our whole. The whole happens when x plus 1 equals 0. That's at x equals negative 1. So the x coordinate of the whole is negative 1. And then to figure out the y coordinate, we're going to plug that negative 1 into this remaining function here in the red. That's going to be negative 3 over negative 2, which is positive 3 over 2, or 1.5, however you want to write that. That's the y coordinate for the whole. Okay, we will have a vertical asymptote when x minus 1 equals 0, and that happens when x equals 1. So my VA is x equals 1, the vertical line. And we will have 1, 0. And that will happen when x minus 2 equals 0. So x equals 2. And we write that down on our list, and that would go in the chart for the zeros. And we're just going to write, we already know the ordered pair is 2 comma 0, so just write 2 for the 0. We know the y coordinate's 0. That's why they call it a 0. Okay, so I ran through some examples from the chart. This is the idea. We're finding the 4 features. We examine the degrees to get the horizontal asymptotes, and then we factor to get the remaining 3 features. For wholes, they cross out or cancel. For vertical asymptote, you look at the denominator, and for zeros, you look at the numerator. I hope this helped. Good luck, and we'll see you soon.